I have to start with a confession. I have a very deep aversion to operating system security patching. And that was my main motivation to get into serverless technologies. I don't think it's the right motivation, but it's a very strong one. It started about 10 years ago when I joined a financial firm. They gave me the small task of patching Windows desktops. It was about 100,000 desktops each month with a team of 7 people. So Patch Tuesday came. By the end of the week, we had to patch our own machines to see if anything broke. Next week, we patched most of everything else. And by the end of the month, we patched the broken ones too. So with 100,000 machines, if you have only 1% of failures for any reason, you have to fix 1,000 machines. Yeah, so I didn't really like that. The only thing back then that I could do was automate the hell out of it. I did automation for our documentation on what kind of patches are going out. I did automation for our dependency management, what kind of applications are going to break because of these patches. Obviously, automation around how we deploy the patches and how we report on those patches deployed. Fast forward a few years, a few new technologies came out, and 2 years ago, I started at a startup. And one day, the web developer came over to me and said, hey, I got this Linux web server. Would you want to take over maintaining it? And my answer was a resounding, let's see what you got. We'll see. So at that point, I had this spidey sense that told me that maybe this is the time to look into serverless technologies and maybe get away from that web server. Again, very bad reasons, but very strong motivation. So I got into serverless technologies. What is serverless? So serverless, what I thought means that servers are somebody else's problem. That is kind of true, but that's not really the point. I brought you a definition from the internet. Yeah, that's how good it gets. Serverless trend changes the abstractions used in software development with downstream implications on how the software is deployed and maintained. Serverless removes the server concept during the software development. I wish I knew this before because I was in DevOps and not software development only. But this was the first thing that I realized that, oh wait, serverless is primarily for the developers and everything else is just trickling down. So that's what focus on code means. I'm not going to focus on what kind of infrastructure I have, what's my IP address, how much CPU usage I'm going to use, or do I need a bigger server to run this application. I'm going to focus on a business unit or a code that is not just a big service, but a business. I can't remember what I called this. A business logic, that's what it is. So instead of writing a big service and then deploying it on a server, I'm going to just write a module of that service and deploy it in a serverless environment. So I'm going to focus on these well-defined business units, the business logic. What else? Oh, it's there. Just tell me to use my slides and then we'll be fine. So it promises free maintenance, and I'm already quoting it, and scalability. I'm not quoting that. That's good. So it promises free maintenance in the sense that instead of doing your own maintenance, you can consider that as a service. In my case, Amazon is going to do my OS security patches. Yes. And not me. So I don't need an operations team just to sit down to the servers and make sure that they are still running. Scalability, same thing. Instead of building my own load balancers, building my own infrastructure just to be redundant and scalable, I'm just going to let Amazon do this for me, which is quite powerful. And the new thing that it introduces that I wasn't really aware of is granular pricing. So instead of paying for resources, buying a server that's going to run 24/7 and paying for all of that 24/7, I'm just only going to buy just enough services Seb, don't look at me. I'm just going to buy just enough that my workload can run, and then get the rest away. That's not my problem anymore. Okay, these are quite good promises. If it's delivering or not, we'll see. So just a very little lookout on the industry right now. A lot of people are going into microservices architectures, and if you remember, focus on the code and remember the business logic, yeah, microservices architecture kind of did the same thing. So if you have a microservices architecture, you're halfway there. That sounds pretty good. Right now, we're looking at the Lambda functions. Everyone wants to do Lambda functions and get away from servers. We're going to get into Lambda functions a little bit more. And we never know what the future holds, but there's talk. So I'm in the blockchain space. Everyone's talking about distributed functions that are not running in a central AWS Amazon, but on people's machines. Interesting concept. Other people are talking about getting rid of functions completely, and maybe call from my web service into the database directly. We'll see. That's what the future holds. That's not today's topic. Before I go into my first user experience with this little web server that I just mentioned, let's go through the AWS Lambda function promises just a little bit, just so you get something before we actually get to the juicy part of Lambda functions. So no servers to manage. That is true. Everything is done by AWS. I don't do security patching. Continuous scaling. So Lambda functions in AWS start running when you have a trigger. So for example, a web request comes in, and my Lambda function triggers that now I have to do some kind of work. It runs the function and outputs whatever it did, and then stops. And I'm only paying for the part that when it was running, when it was actually running the whole function. So it's very easy to scale that because I can have yet another Lambda function right next to it doing the second request that just came in at the same time, and yet another right next to it. And because these are mostly independent functions, you can run as many as you want. And AWS is going to take care of that scalability for you. If you have 10,000 requests every minute, then it's going to ramp up as many Lambda functions to run as you need to serve all your load and then shut them down. So scale to the point to fit your workload and then get rid of it. Sub-second metering is something that was new because the granular pricing was new to me in general. They start charging for the first 100 millisecond, and in a 100 millisecond slot, you get charged. So if your function runs for a second, then you get charged 10 units, and that's it. This is actually sounds interesting, but it's a whole new mindset. Because what did I do before? I prepaid for a service which was running 24/7. If I used it only 10% of the time, it was still a fixed price. Now, how much am I paying? Well, how many requests did I have today or in the past month? So the whole how much am I paying is going to become how much am I using my own service, which is very interesting. Multiple languages supported. You can write Lambda functions in Java, Ruby, C#, PowerShell, Node.js, Golang, and the list is not complete. So AWS is coming up with new and new languages to write your functions in. OK, so let's go to that user story. So my little web developer told me that here's the keys to the server. Look around. So yeah, it was a Linode web server, about $20 a month, and with an unpatched Ubuntu 14. I'm not trying to make them look bad. They are great people. It's not their expertise. So, but I had a server to patch. Oh no. Source control. So fortunately, they were very mature in how they handle their own source code for the web page. It was in GitHub, perfect, that they pulled onto the live web server and built it there and moved it over to the production place. So that's a very good reuse of resources. I already paid for that, and I'm not using it as a web server. But maybe the build process should not take away the production resources for handling the web service. And we were using Let's Encrypt, which is a very good solution, except we had an outage every 3 months. Because Let's Encrypt recertifies your certificate every 3 months. And after that new certificate comes on your machine, you need to reload your Nginx to actually load it so you can serve it. And obviously, the cron job wasn't running properly, and no one looked at it before. So they asked me about, can we please do this automatically? That's my only request. Instead of me typing in git pull, a cron job should type in git pull when I have a change in my GitHub repo. Yeah, that's a fair request. Scalability, so that was my concern. What happens if we get slash dotted? Who knows what slash dotted means? Oh, awesome. Okay, I'm not too old yet. So if some news come out of our services and a lot of users start looking at our web service all at once, then they can overload my Linode server, even though it's a big server. It's the best. So I wanted to make it more scalable and possibly not really put more Linode servers in place. And with all the cloud infrastructure, I hope everyone understands now that you are on ephemeral infrastructure. If the server goes down because the cloud provider says, sorry, there was a hardware failure, then it's gone. Does everyone understand that now, right? I see some faces that have that look, the PTSD look. Yes, I get it. So we didn't really have any way of rebooting that server and setting it up again because obviously no one took any documentation about it. So we wanted to change that. Before I go to the solution that we put in place, I want to go into some of the tool set that you can use. Most probably you know and use some of these already. This is just slightly modified release management for serverless technologies. So obviously you have some kind of source code management tool. Our choice was GitHub because it's an open source tool. We're an open source shop. It was a good fit. We're looking into GitLab now because they're cool. And they're here. They have a booth here. For orchestration, I used Jenkins initially because I had the experience. Everyone has experience with Jenkins, good or bad. And then I realized that because I decided on Jenkins for the short term because that's easy for me to set up, I actually bumped into another problem because all my developers were using CircleCI for their testing. So adoption all over the company was really bad. No one wanted to use Jenkins if we already use something else that works for us. So after a year, I moved on to CircleCI. For me, it doesn't really matter. It gets the job done, right? For deployment, now this is where serverless derails a little bit. There are some additional tools for doing deployment for serverless technologies. If you want to deploy a Lambda function, serverless framework on serverless.com is a Node.js framework that you can use to very easily deploy Lambda functions into your environment. I didn't like Node.js, so I didn't use serverless. I went with Terraform because Terraform is cool, and I think they sponsored this event also. There was a 30-minute pitch with Terraform. And there is an introductory Terraform talk, I think, tomorrow. If you don't know Terraform, I highly encourage you to go to that talk. It's introductory. You have to make some decisions on what kind of infrastructure, what kind of cloud provider you're going to go with. AWS was our choice for 2 reasons. That's what I know best, which is the worst of the reasons. The better one is that AWS is the most advanced right now. We are actually looking into alternate solutions all the time because we don't necessarily agree with AWS's practices in all fronts, like open source. We are an open source company. Talk to the Elastic Cloud guys here, Elasticsearch Clouds here. But if you're into Google, then Google has Cloud Functions, or Auth0, if you ever heard of them, has web tasks, or there are other options. Last but not least, you will need some kind of monitoring in place. You can go with CloudWatch or your favorite Datadog or whichever you want. You might need some databases. This is out of scope for this talk because it didn't really change that much. So what did we do? So I wanted to use the same GitHub repo that we have, but I wanted to deploy a brand new infrastructure based on AWS that, yeah, I should somehow raise this. I know that there's a lot of heads in front of you guys. Sorry about that. I wanted to deploy a completely new infrastructure that I can step away from. The whole point was that I don't want to keep maintaining that. I want to get into some cool projects. So I used Terraform to describe my infrastructure. Just did the pitch on it in a slide ago. And GitHub stores my Terraform code. The main point here is CloudFront. CloudFront is an AWS offering that allows you to cache files all over the environment, all over the world, actually. It's a web cache solution like Cloudflare, if you heard of Cloudflare, or Akamai, if you're an older type of guy like I am, then you might have heard of them. I need to store my source files somewhere, so S3 was used to store the files where CloudFront gets the files from and then caches it all over the world. And my website needs some kind of domain name, so Route 53 is perfect for that. ACM, has anyone used ACM or Certificate Manager in AWS before? Hands up. Oh, awesome. So I didn't actually know about this technology before I started deploying this. It allows you to deploy your own free SSL certificate for your domain, and it's free. I mean, this one is really free, at least if SSI is something that you don't worry about. I'm not going to go into that detail. Look it up. Because if it's not, then it's $600 a month. So Terraform can actually provide me with the full environment in a shape there where all the necessary connections are there, which was pretty nice. I use IAM because the whole thing here is literally just the infrastructure I put in place for the developers to be able to deploy their new versions of the website. So IAM is necessary because I had to have a user which have a limited access to S3 and CloudFront to deploy a new version of the website. They already have GitHub access. I didn't really need to worry about that. So what happens when I want to deploy? And this is what the developers should be able to do by themselves. And if I change Jenkins from Jenkins to Circle CI, actually in both cases, they can have their own little deployment file on their own repository. So Jenkins file in one case or config.yaml in the other case. So they have their source code in GitHub. They submit a change. Jenkins picks it up. Yarn, Node.js, whatever you use to compile your website, does it on your orchestration tool. And then it deploys to S3 using the S3 credentials that it was given. Why is the CloudFront still there? So after I've deployed to S3, the caches are not updated yet. It takes 24 to 48 hours, if I recall, to update the caches by themselves. We live in an impatient world. So instead of waiting for that 24, 48 hours, I want to invalidate all the cache and just deploy the website real for all the endpoints. So that's why you need CloudFront invalidation access to the for the orchestration tool. Now, here's some of the caveat that I want to raise. So invalidations cost money. If you want to redeploy your whole website, it will cost you some money. Fortunately, the first 10,000 invalidations are free on AWS, and then it's 5,000 of a cent or something like that per invalidation. Or 1 million invalidation for $5 or something like that. But what you can do is, especially if you have a smaller website, you can tell CloudFront to invalidate the whole website, which will cost you one request. So instead of going file by file and invalidating all of them, one request to invalidate the whole website, and it gets redeployed to all over the world. If you have a big website, you might want to go more granular because you might need to upload gigabytes of data from S3 to your CloudFront endpoints. There is supposed to be a little animation here which doesn't work, unfortunately. Mac and PowerPoint don't mix well. Because I run into an issue here. This environment exactly fit what I had as a request from the web developer. And then what comes next? Scope creep. So they come to you and say, oh, by the way, could you please change the content header on this file? Oh, and by the way, could you redirect this endpoint to that endpoint? And S3 and CloudFront together cannot do that. In this scenario, when you get your files directly from S3, this is not an option. It's literally meant for a static website, so OK, now what? Fortunately, S3 has a static website option, which will allow you to do just an HTTP website on top of your S3 objects, which allows you to have metadata for the objects like content type or where you want to redirect to. And if you point CloudFront to that specific HTTP endpoint, then it will pull in all those extra details. So I had to add the static website functionality. And now you might ask, then why am I using S3 even? Because I could do that with the Linode server, right? Keep the Linode server as my source, use CloudFront as the caching mechanism, and I still didn't overload my Linode server. That is true. You can do that if you're into that, or somehow that makes more sense to you, you can do that. In my case, I just didn't want to do OS patching, so I didn't want any servers around me. That's what it is. It is actually, I think the next slide will talk about money. Yes, so the Linode server we had cost us $20. 2 CPUs, 4 gigs of RAM, 80 gigs of hard drive. Sounds good, especially if I only use it as a backend. But storing a terabyte of data in S3 is, can someone tell me how much it is? 10 cents? Well, for a gigabyte of data, it's 0.0023 or something like that. And I think for a terabyte of data, you pay $23. But do you have a website with a terabyte of data? Does anyone here? No? OK, good. So it's cheaper. And also, it's redundant. Come on, S3 is redundant, so I don't need to worry about the server going down and losing all my data, even if it's backed up. So what did I find? If I have a website with 100 gigabytes of traffic each month, and the website is, let's say, up to 1 gigabyte big, it will cost me around $15, 20, I put in 20 just to make it comparable, but around $50 to maintain that without any servers. $10 for the traffic and around $5 for the rest of it, which is not so bad. It's redundant, it's scalable, I liked it. Now, where the trick comes is if you try to scale that, it can become expensive. If I actually spend 4 terabytes of data a month, then yeah, that's about $500. If I have a server that needs to spend 4 terabytes of data, how many servers would you deploy? It might be cheaper or more expensive in your scenario. So one thing that I learned is each scenario is different. When you're doing the pricing, look up the pricing pages on AWS and make your own pricing for each of your projects. That's very important. But in my scenario, this worked out really well because I didn't need a server. Oh. OK, I didn't talk about Lambda, though. But I don't have a server. So let's move on with my story. And I can talk about Lambda now. Can someone tell me the time? Because I don't see that anyone's looking at it. 4:27. Thank you. So, OK, again, same web developer comes to me and says, hey, we'd like to create a faucet application, which is a very simple website. You type in your, as I said, I'm in the blockchain space. You type in your wallet, and you get some coins. Obviously not real Bitcoins or anything, but we had a few testnets up and running. We wanted to enable the developers to have their own coins on the testnet or tokens, and then develop their own application. So that cannot be done in JavaScript, unfortunately. Not yet, at least. We are working on it. So I need some kind of backend now. With the original website, with all JavaScript on the client side, I really didn't need anything. So faucet page with a backend API. Again, microservices architecture. Is anyone in the microservices architecture business? OK, there's a few people. Congrats. I think that's the way forward, or some version of that. Obviously, the developers already had the solution ready, and I just needed to deploy it. Have you ever been in that scenario where, oh, it's working, here, deploy it to prod? They had a built-in web server on that little code without any kind of either authentication or SSL or nothing. So you have to build a whole infrastructure around it. But we didn't actually want users to authenticate themselves on the website. So it's going to be an open API. Anyone can come and ask for some tokens. Maybe implementing reCAPTCHA is a good idea, because then you can't just write a script and gather all the tokens on your testnet. So my requirements were, yeah, I still don't want servers. But I still have to make this scalable, because this is definitely the kind of /dot environment where we tell people that we have a new testnet, 1,000 people want to really, really get some tokens right now, and the next day there's nothing happening. And that was, again, a very nice, cute little project that I want to set and forget and get on with some more cool stuff. So what did I do? And I'm separating these pictures into creation and deployment because we're a DevOps shop. We're not really interested in the code itself. We're more interested in how the infrastructure will look like. So same thing, Terraform in GitHub. And the most important part is there's the Lambda function on the bottom right. So what does this Lambda function do? What does it do? The Lambda function is a RESTful API service. Or at least that was the goal, to make it a RESTful API, with one little endpoint that says, send me some money. And the front end, also in JavaScript, will call that endpoint and send you some money with the payload of the wallet address. Obviously, because of the testnet also had an API, this Lambda function was calling into that testnet API to actually do the transaction and return you the result of, hey, you got some money. Sorry, I'm using tokens, coins, and money interchangeably. I'm talking about tokens. Okay. Unfortunately, Lambda functions by themselves, at the time when we were doing this, were not, you couldn't really call into them from JavaScript. Maybe you could, we didn't really want to. So we used API gateway in front of the Lambda function to define how our API, actually the RESTful API, looks like. So define all the endpoints in your API gateway, and the endpoint, so when the endpoint is triggered, it will trigger the Lambda function to do the actual work and return the result to your web browser. I mentioned WAF, or web application firewall, here as an extension to this API gateway. If you want to limit IP addresses or some kind of authentication method, you can do that by connecting to this web application firewall to your API gateway. So it's not your Lambda function's responsibility to authenticate the user, for example, which is pretty cool from a software developer perspective. I'm not working on authentication. I'm working on the real code that I want it to be, want it to do. I just mentioned DynamoDB because in my specific case, I needed to store some extra information. You can use environment variables. Lambda function supports environment variables, and they are safe and secure. You can package additional files to your Lambda function as you upload it to AWS if you need to add some extra code or extra information to your Lambda function. Or you can use any database that you like. So RDS, MySQL, whatever you have in mind. What you have to be aware of is that this Lambda function has a limited amount of time to execute. And this is a hard stop there. So the maximum amount of time you can execute a Lambda function right now in AWS is 15 minutes. So if you want to call into the Lambda function and make it run for 30 minutes because it's doing some testing for you or some calculations, you need to find something else. Or you need to cut it into different steps, like the Lambda function does the call in, but you use some kind of EC2 instance to do the actual calculation, which will again trigger another Lambda function to get you the results at the end. So you need to have a different viewpoint of how you're writing your application. But for RESTful APIs, it's quite good. RESTful APIs usually have a limited time to execute because you need to get back to the user. Usually it's limited in what it does. So an endpoint is usually a specific business logic, like /user, /product. So it fits really well with the Lambda function idea. And again, for the deployment, I needed an IAM user, so the developer can actually access the API gateway if they want to add more endpoints, and the Lambda function to update the actual code. And that's what you're going to see on the next slide. So we are a Go shop. We use Golang for everything. And that was the main reason why we only looked at Lambda functions in 2018 when AWS introduced the Go language support in Lambda. So Jenkins builds your Go language binary and uploads it to the Lambda function. If you have any additional optional new endpoints, then you change your API gateway. You can also add stuff into your DynamoDB if your schema changed or if you have extra additional information for your new version of your application. And it worked pretty well. So our faucet for our test nets were serverless with Lambda functions. Okay, this is what I wanted. I stepped away and I didn't look back until the next version of our testnet came, which broke the whole API calls in our Lambda function and had to update the code. But I can throw that off to the developer because they know Go. So I don't need to write that myself. Okay, pricing. Again, I could use a Linode server or EC2 instance. Again, let's go with the $20. How much does AWS Lambda cost? So the Lambda itself, if it's not running, it doesn't cost anything. That's crazy. If it's running, it's on the, yeah. If it's running, you have to define how much memory you want the Lambda function to use. The smallest amount you can define is 128 megabytes. If you define that, you have 3 million something seconds that you can use for free in the free tier of AWS. And in the Lambda function's case, this free tier doesn't go away after a year, which means that I can effectively run it for free because 3 million something seconds boils down to 37 days a month. Okay. And I can run 1 million requests for free. Yeah, if this is a very busy website, then it will add up, and maybe 1 million requests will not be enough. In my case, it was enough. We don't have that many developers. Usually, we just have to worry about the hackers who want to just pull our services and make sure that we use up all our resources. Why did I put $3.5 there? Because the API gateway requests cost money. So the 1 million requests through the API gateway cost me $3, which is quite okay. Again, let's scale that up to, instead of 128 megabytes of RAM, let's use 3 gigabytes of RAM. But let's be reasonable. We're not going to run this 24/7. We run it about 8 hours a day. And we have 100 million requests. So that scales to $405. I can't really recall which part was the biggest. Oh yeah, because you only have a day and a half of free tier Lambda, and you're paying for each execution afterwards. So it adds up. Is this a lot? Is this not a lot? Yeah, you're giving me the right answer. How should I know? I have to check my own project and see if it's good for me, right? But instead of just being cheap, now I have a scaled environment, which is pretty cool because, as I said, Lambda functions will just run as much as you need it, and then they'll stop. What else? Function complexity. So when I was writing my RESTful API, originally I didn't really want to use API gateway, and I was running everything on my local machine. So I wanted to test my endpoint on my local machine. So I had to have some kind of local web service, and I had to have some kind of local routing. And then do I get rid of all of that just so I can push this into Lambda? Well, my decision was no. I kept my Lambda function quite complex because it can resolve multiple endpoints. And I can run it locally as a web service. I have the template open sourced. It's going to be at the end of the slides, so if you want to look into it, you can. But what usually you read in documentation is that Lambda functions are really for simple functions. So just get there, do the stuff, exit. Right, so if I have 2 endpoints, I write 2 Lambda functions. From a developer perspective, this completely makes sense. Yeah, file number 1, Lambda function number 1. File number 2, Lambda function number 2. The deployment kind of becomes a bit cumbersome. So do I manage all the functions separately? Do I manage all of them at once? And if any one changes, I update all of them? I really didn't want to do that. So you have to make your decision if you want to go with simple Lambda functions multiple times for your RESTful API or any number of applications that you're going to use, or a bit more complex and maybe implement a few of the business logic that relate to each other into one Lambda. For example, if I have a /user endpoint, the same Lambda function should be able to support the post, the get, the delete, and all the methods of the endpoint. The same with /product. If I want to make that into a separate Lambda function because maybe it's a different team supporting it, then that's fine, but at least the delete and get and put methods should be managed in the same function. This is actually coming from one of my friends who's doing cloud architecture in AWS over in Montreal. But he's smart. I believe him. You should believe me. I'm on stage. Timeouts. Usually with RESTful APIs, this is not a problem, but in my specific case, because I called into another API and I had to wait for that API to come back to me and figure out if I actually have a normal response, I could run into timeouts. So the default is that your Lambda function will kill itself after 2 seconds. For RESTful APIs, that might be OK. As I said, the maximum is 15 minutes. If you don't know how long your function is going to run, then you might want to either implement some kind of check and do a clean shutdown before your timeout arrives, or maybe look into some other solution if you really can't figure out how long your application is supposed to run. But what I ended up doing is each of the calls that might have a timeout in my code was added, and I said, OK, I have 2 HTTP calls here and a database call there. The timeouts for those are 10 second, 10 second, 30 seconds. So my Lambda function needs to be able to run for up to 50 seconds. In the usual use case, it will be 2 seconds. But if I want to cover all the bases, then the limit should be 50 seconds. I'm telling you this so you make sure that you check this when you're writing your own application. Lambda at edge. So going back to the website example for a second, I mentioned that not all properties of a website management was there. So I was able to set content type, and I was able to do redirections, but I wasn't able to add content headers. So that's not supported even with the static website. So what is supported, though, is you can create a Lambda function for your CloudFront application, throw it there, and your Lambda function is only going to do, what it's only going to do is add headers to your request, to your responses. So, for example, you want to set up content security policy, which can be quite complex in these scenarios, even in these scenarios. Or you want to set up course headers, so your website is not available for anyone else, just for the domains that you want. Lambda at edge is priced differently, and it's specifically for CloudFront, but it's a good solution to add those headers if you don't have anything else. If it becomes more expensive than having your own servers or server park to make it scalable, again, make your own measurements. API gateway deployments. So that was a weird thing about API Gateway. It has its own built-in solution for staging, prod, and dev environments. And you can do deployments of the same code into those different environments, which really just become different endpoints. I really couldn't use it because in my environment, my complete environment is on a different AWS account. I have a dev account, I have a prod account, and now we have an experiments account for developers for some new stuff. So I can't really use any of the development stuff, but maybe that's something that's worth looking at for you guys. I don't know why it's there. So there are a lot of takeaways you can take from these examples. The 3 I want to highlight is we found that if I have underutilized infrastructure that I'm paying for, especially short-term burst-like traffic, then Lambda functions and serverless solutions in general might be good for that kind of work, and I could get away from servers. I mentioned web applications, microservices. If you're already in that mindset, then you're literally a step away from Lambda functions. Have a look at it. Maybe it's for you. Maybe it will free some of your operational time, your maintenance time, and allow you to do something more interesting. Yeah, pricing is tricky. I think I got through that. So pricing is very different with serverless technologies. Instead of leaving it to the CFO to create a budget and then you just use it up for servers, it's better to get into that discussion and give them examples on what they are going to look at, so they don't get very upset when you overuse that budget, which happens. Okay, a few of the resources. I want to highlight the serverless Node.js from Jonas Cheng, if I recall, and a Go Lambda template that I wrote for a more complex RESTful API Lambda function. But the AWS Lambda FAQ is frequently asked questions is also quite good. And I do have a Ask Me Any Questions slide. I'm not going to show it because I think it's better if I just show you this so you can write it down if you want. That is it. Does anyone have any questions? There is one over there. Oh, sorry. Let's go over there.
Have you got any experience with other serverless tools like other providers?
We're looking into Google Cloud Functions right now. I didn't want to add it to the list because we don't have enough experience to tell you what's the right thing to do. Not that I usually do that, but it's a Google Cloud Functions. I mentioned Auth0's Webtask, or IFTTT is a serverless solution, maybe for kids play, but it is still serverless. Someone mentioned Redshift. I don't know if that's considered a serverless solution. I didn't really look into that yet. So I'm not an expert on all the serverless, unfortunately. It's mostly Amazon related. You had a question?
Just about the infrastructure deployment, because you said you were using Terraform.
Yes.
Can you sort of give your take on the serverless framework and how that compares to Terraform or with CloudFormation?
Okay, so the question is, can I compare Terraform to serverless framework to CloudFormation for deployment of infrastructure? I can somewhat. So I didn't use serverless framework because it was written in Node.js and I just didn't want to get into it. But if you're a Node.js guy, then start with that. It's literally written for the guys who are already in that space. As for CloudFormation versus Terraform, I actually started out with CloudFormation. Why not go all in with Amazon? I didn't really have a good personal experience with it. I'm not going to compare it to anything, but the way they form their JSON and the way you can manually edit it, but then figure out where you missed that comma was not really for me. So I used it for a while. They have staging and different kind of deployment methods, which is pretty cool. And then I just saw Terraform, which was based in Go language. We are a Go shop. We can write our own providers if we want. We added some code to some of the providers. So that's all the experience I have with this. Okay, but all three are supposed to be able to deploy your serverless code. Well, serverless framework is more for the Lambda function, but Terraform and CloudFormation both should be able to deploy your code. It's a personal preference.
The serverless framework is not based on CloudFormation or anything like
that? No. Wait, sorry. No, I can't really answer that. It is based on one of these. It might be CloudFormation. Sorry. I can't really answer that. You have to look it up. Or I can look it up. Any other questions? Okay, very good question. What kind of practices can you put in place to prevent bots to use up all your resources? So I mentioned the web application firewall, which is definitely there to help you out. Web application firewall can limit your IP range. It can set up throttling. I think API Gateway has built-in throttling also. So that can help you with some of these requests. Unfortunately, in my case, because I didn't really have any kind of authentication, at one point you could just write a script, find the URL of the Lambda function, and start hammering it. And that was something that I had to consider. One thing that we implemented, as I mentioned, was reCAPTCHA to throw away requests that are not valid because they didn't come from the website. And that's actually pretty cool, but if someone's just malicious and they just want to abuse your services, that's not going to stop them. The other thing I was trying to implement is, does API Gateway have any limitations for how many requests you can send per second to your AWS Lambda? It does, unfortunately, in the thousands. So if, after a few thousand requests, you can limit it, throttle it to a lower bandwidth. In my case, because it was a user-facing website, I really wanted something like you can make 10 requests per minute from the same IP address. That throttling is not really available in API Gateway. I did implement it in my Lambda function, though. So if someone came from an IP address that was already in my DynamoDB list of blacklisted IP addresses, then I just throw away the call. I didn't really eliminate all the money that I'm going to pour into these kind of requests, but instead of going through all the Lambda functions lifetime, I was able to eliminate them in the first 100 milliseconds.
How's your experience with the Lambda activation time?
Oh, amazing question. I really wanted to discuss this on the slides too. I guess I didn't have enough time. So when you spin up your Lambda function, it has a cold boot period. The first run of your function is going to take maybe up to a second. That's not very nice on a website, right? So I have to wait for a second just because something's happening on the back end. I don't even know what's happening. So the cold boot period is actually maintainable in your code. So you can use it to spin up your database connectivity, make sure that your environment is as it should be, you're healthy. I even implemented some kind of self-healing regeneration in my database in that cold boot process because in my specific case, unfortunately, I wasn't completely independent from each of the Lambda functions. After that cold boot process, though, the Lambda function doesn't shut down right when you finished your processing. Amazon allows you to run it for, I think, about up to 5 minutes. I can't really recall if there's a specific limitation on it. And it's just hanging out there. It's doing nothing. You're not paying for it. But if there's a new request coming in, it's not going to spin up another Lambda function. It's going to reuse the one that's already available. So if you have requests quite frequently, then the cold boot is not going to really affect you. If you're worried about that cold boot affecting you, then after your deployment, do a request. Make that cold boot yours. And then the rest of the users are going to use that warmed up Lambda function. Awesome question. What kind of monitoring or observability? Yeah, I didn't set that up, I guess. I can't even say it. Set up for your Lambda functions. So CloudWatch is built into most of the technologies that I've shown, API Gateway, Lambda function. The Lambda function by default logs into CloudWatch. So in my specific case, I use some other service providers, Datadog and SignalFX, to monitor my environment. They use CloudWatch's metrics. You can also build your own metrics, APM metrics, into your own Go code. And there's Amazon's X-Ray service, which will allow you some kind of APM for your Lambda functions also. Because this was a quite low priority project that I was building, I mainly just used CloudWatch to figure out what went wrong. And as I mentioned, I built in this kind of self-healing capability that if one of the requests failed for any reason, the next one was looking at the failure and fixing it and then running from there. Okay, if no other questions, then I'm just going to close it here. Thank you for attending. I hope we meet on the floor.